right, this video is for part 2 of your review. We're going to do numbers 1 through 4. All right, so in a geometric sequence, it's known that the first term is -1 and the fourth term is 64. Find the value of a sub 10. So we know that we're looking at a geometric sequence, which is this formula right here. You can use that formula for the whole thing. The faster way that I think I like to do it is fill in some blanks. I know the first term, second, third, fourth term. So I know the first term is -1, the fourth term is 64. I first need to find the common ratio. And to me, the way I like to do this is almost like what we did with arithmetic back in part 1, number 3 and 4. I'm going to say start at number 1. Now here I'm going to multiply by r, by r, by r. Now when I multiply by r, by r, by r, there's a faster way to do r times r times r, and that's r cubed. So I'm going to rewrite this as -1 r cubed equals 64. I have to divide by -1 first. Gives me r cubed equals -64, and then take the cubed root. The cubed root of -64 is -4. So that's really helpful because now I know everything I need to use that sequence formula. I can find the 10th term by saying, okay, the first term is -1, by r is -4, to the 10 minus 1 power. All right, so I'm going to have, let's see, -1 times -4 to the 10 minus 1, and that's it. 2, 6, 2, 1, 4, 4. There you go. Nice and easy. All right, second problem. Find the sum of the arithmetic series of 20 terms whose last term is equal to 97 and the common difference is 5. So we're using this S sub n for arithmetic series. This guy right here. Now, let's fill out what we know. We know n. We know it's the sum of 20 terms whose last term, so that'd be a sub 20, is 97, and the common difference is 5. When I look at this formula, I know the n, I know the last term, I don't know a sub 1. So I actually have to find the first term first before I can do anything else and before I can find the sum. So to find the first term, I'm going to use the a sub n formula. Okay? I know the nth term, a sub n, is going to be 97. I don't know the first term. I do know the common difference is 5, and its n is 20. So I'll have 5 times 19, so I'll have 97 equals the first term plus 95. Subtract 95, and I get that the first term is 2. Well, that's really helpful because now I don't need to do much to find the sum of those 20 terms. Put everything into my formula. N over 2, first term plus the 20th term. And take my word for it, when I type that into the calculator, I get 990, because this is 99 times 10, which is 990. And there's your sum. So a little bit harder because you had to find the first term, figure out how to do that before you moved on. All right, part 3, express the sum using sigma notation, then evaluate it. So you need to decide what type of sequence this is, or series. 138 plus 126 plus 114. Let's see, it looks like I'm subtracting 12 here. Yep, that seems to work. So this is going to be arithmetic series with a d of -12. All right, now, in order to express the sum in sigma notation, the first thing I need to do, because remember we're going to use sigma right here, I need to come up with the equation that comes after the sigma. So I need to come up with the a sub n formula. To do that, I'm going to use this formula right here. So I know my first term is 138. I know my common difference is 12 times n minus 1. I distribute the -12, and combine like terms, so that's 150 minus 12n, or negative 12n plus 150. It doesn't matter how you write it. That formula goes right here. I'm going to write the negative 12 first. That's the first thing I have. Now the next thing I have is the indexes. I can assume that 138 is the first term, so I'm adding up from the first term to something up here. I need to find that index. That last term in the sequence is negative 270. I need to find what is its n. A sub what, right? That's the n I'm looking for. So the way I do that is I'm going to take that last term and set it equal to this fancy equation I just found for the sequence. That is the sequence formula, so if I can solve that for n, that'll tell me the term of negative 270. So I'm going to subtract 150. I get negative 420 equals negative 12n, and divide by negative 12. So here, n equals 35. That's my top index. I know it's kind of messy work here, but all I need to do now is type that into my calculator. So I'll have math 0. I'm summing from the first term to the 35th term, and then my equation, negative 12x plus 150. And that looks like the answer on my paper. That's good. Negative 2310. So that is ultimately what we were after. We needed to do all that other work first. All right, last one for this video. Express the sum using sigma notation, then evaluate. Now this sequence is going to be geometric. If I start at 1/4, it looks like I'm going to multiply by negative 3 to get to the next term. Then negative 3/4 times negative 3 again gets me to positive 9/4. I'm alternating signs. So this is geometric, and my r is negative 3. So in order to write sigma notation, geometric is a lot easier. You jump right to writing the formula. Now my first term is 1/4. My common ratio is negative 3, and then n minus 1. Now the indexes here are also easy because 1/4 is the first term, and it doesn't tell me what the 12th term is, but I do know that the n is 12. So simply, all I have to do now is type that into my calculator. So I'll do math 0. We're adding from the first term to the 12th. Now just be careful typing your formula. You are welcome to use 0.25 instead of typing the fraction 1/4. Make sure you put the r that's negative in parentheses, and then x minus 1. And there you go, negative 33,250. And that's what we're looking for. All right, there's one more video for part 2. Come back if you need help with that.